Thanks. Yeah, so my name is Stephanie. I work at a startup called Brigade. I'm an engineer there. And actually, I used to work at Twitter, so it's really, oh, really? Sorry. Can you hear me now? Okay, great. So I work at a small startup called Brigade, and I actually used to work here at Twitter for a couple of years before I went there. And today I'm going to be talking about how we use Scala and Finagle to scale out our Rails application at Brigade. So for some background, and I promise that this will be pretty short, Brigade is a social network for voters. And so what we do is we try to provide a platform where users can have discussions about politics and become more informed citizens overall. Our application was originally built using Ruby on Rails, and that's still where the majority of our functionality still lies. So obviously, Rails has a lot going for it. It allows you to do really quick development, and it provides lots of really nice to use libraries like Active Record, which is just an ORM for Rails. And it also has really great community. But there are some drawbacks, namely performance is just not quite as good as the JVM. There's really a lack of concurrency in Rails and in other libraries that it supports. And it, of course, uses Ruby, which is a dynamically typed language. I probably don't need to explain to a bunch of Scala people why using a statically typed language might be a nice thing sometimes. So on Brigade, in order to explain kind of why we decided to scale out our microservices architecture in the end, I'm going to have to explain a little bit more about the platform. And so one of the core components of Brigade is this thing called a position. And this position or debate, you can see an example right here. It reads, "The Democratic establishment has misunderstood this election by heavily favoring an establishment candidate." So that's a position. And as a user, you can either agree or disagree with this position. We also provide something as a core feature called alignment. And what alignment is, it represents how aligned you are ideologically with someone else on the platform. And that's what's circled on the right there. And so when you agree with a position and someone else also agrees with that position, that counts towards your alignment with that person. And so that's represented by this percentage score. So alignment is shown a bunch of different places on the platform, including on the profile, which you were just looking at, but also on this ballot guide, which we were offering during the election season. And so in this case, instead of comparing two profiles, we're comparing a profile with a group of profiles, namely people who've pledged for Jill Stein in this case, or Hillary below. And so this measurement of alignment is sort of shown everywhere in the product, and for product reasons, it really needs to be a real-time measurement. However, this was basically how we were calculating that measurement. We were using an SQL query, and you can see basically what this does is it does a join on position responses and sort of aggregates how many position responses you overlap with the person on. And so this can be really expensive considering that this computation needs to happen multiple times per page view per person. And so at its worst, I think the P99 latency was something like 10 seconds, which is pretty unreasonable. So this is the performance bottleneck that really inspired us to actually build out our first microservice. However, as you might know already, moving towards a microservice architecture introduces a lot of new problems. Namely, debuggability becomes more difficult because now your computation doesn't lie in one place, it lies in multiple places, and you need to figure out how you're going to build systems that are easy to debug. Also, you have complexity with data access that you need to manage. So previously, you had a Rails app which managed its own data, and now you have several services that potentially need access to that data. So how do you enable that? And then finally, you need to integrate these services with your app across different environments. And namely in testing and dev, since those are sort of environments that you don't really think about when you're kind of designing your architecture. And so in this talk, I'm going to explain some of the decisions we made while building out our microservices and how we address those issues that I sort of outlined here while moving towards that architecture. So first of all, why did we use Scala? There are a few reasons. We wanted the performance of the JVM, and we also wanted the support for asynchronous computation that it provides. For Scala specifically, we really wanted and appreciated the static typing that it provided us, and possibly most importantly, we were already using Scala in our data pipeline, and since my team, the data team, was charged with implementing these microservices, it was a pretty easy choice for us to make. So as you may have guessed from the title of this talk, we decided to use Finagle as the framework for all of our microservices, and one of the reasons for this was we really appreciated the simplicity of features. Twitter features are essentially the same as Scala features in that they just represent the result of a computation that hasn't necessarily completed yet. And it allows us to do some really simple composition of features both concurrently and sequentially. And so in this example, we're using this fetch URL. In this example, I kind of just stole from the Finagle documentation. So you can, if I explain it poorly or you get or if it's too quick, you can just take a look at that there. But basically, fetch URL returns a feature of a response, and then we use that result to fetch more URLs concurrently, and then we can collect them using this feature.collect to return the final result. And so that all happens in 3 lines. It's very simple and nice to use. So Finagle also, one thing that we also really enjoyed about Finagle was how it represents a service as a function. And what I mean by this is that it abstracts a service as basically a function that takes a request type and returns a feature of a response type. And it also defines a construct called a filter, which can be composed with a service in the same way that 2 functions can be composed. So it can basically wrap that service to create a new service. And so that can be used to do things like doing timeouts or authorization. And in our case, we use it to do things like translating requests and responses into a more debug-friendly format. And I'll elaborate on that a little bit more in a bit. So Finagle also supports a bunch of different protocols, including Thrift, HTTP, MySQL, and Redis, which are all things that we use. And so this means that we have the flexibility to implement services that speak both Thrift and HTTP, and we can use the same framework to talk to other services as well as our databases. However, for the majority of our microservices, we decided to default to using Thrift. And the reason for this was Thrift, compared to HTTP, provides a much stricter agreement between the client and the service. And that means that there's no ambiguity over what parameters a request takes or what the response body looks like. And so it does all that validation and parsing for you. One nice thing about using Thrift with Finagle is that Twitter actually wrote a Thrift Scala code generator called Scrooge, which works really well with Finagle. And so in this example, I've defined a Thrift service with one endpoint, profile alignment, and then using Scrooge, it generates an interface for that service. And you can see that it has this profile alignment endpoint, which is just a service taking the request type and the response type. Also, by using Scrooge, you get to avoid using the Java-generated Thrift code, which can be a lot clunkier, especially when you're using it in Scala. And so on the top, I've created a Thrift object using the Java-generated code. And you can see that I first have to instantiate an empty object, and then I set the profile ID in the second line, which kind of violates this immutability thing that we usually follow in Scala. And then if I want to actually use that profile ID, I first have to check if it's set to use it safely, because otherwise, if it's not set, it's null. So instead, using the Scrooge generated code, I can just instantiate the profile alignment with a profile ID in one line, and all the other fields are just defaulted to none. And then if I want to use that profile ID, I can interact with it as an option. So I can check if it's defined, or if I can map over that value. So if you're paying attention, there are three things that I wanted to talk about, which were potentially problems when moving towards a microservices architecture. And debuggability was the first one. And so if you're working in a Rails app, debugging your app can be pretty easy generally. All you have to do is open a Rails console on your running service, and then run your commands there. And it's pretty easy because you have a really nice REPL and console to do that in. When I was preparing this talk, I was going to say that you can't really do that with a running Scala service, but I found out that you can actually do that. I think you can use something like Scala Live and actually bind to a running service by binding to that process, but I actually haven't had time to go over how to use that. So I'll talk about how we at Brigade decided to approach enabling our services to be more debuggable. So one way that we decided to address this was by implementing a Thrift to HTTP filter, which we can compose with a Thrift service. And by composing it with that Thrift service, it basically converts that Thrift service into an HTTP service, which takes a readable JSON request and returns a readable JSON response. And so we expose an HTTP port on all of our Thrift services that basically exposes all the endpoints that that service implements, so that developers can just send a curl request to see what kind of response they'll get for a certain request. However, we found that the JSON protocol that Thrift provides is extremely difficult to read and write by hand. And so for those of you who aren't really familiar with Thrift, Thrift provides several different protocols, both binary and JSON, to serialize Thrift objects. However, it only has one JSON protocol that's both readable and writable. But it's really hard to do so as a human. And so what I mean by that is this. So I've created a Thrift object here, and then I've serialized that exact Thrift object as JSON using the tJSON protocol. And you can see that it doesn't really include any of the field names. It just uses the number of those attributes as defined in the Thrift definitions, which makes it really hard to read unless you're sort of OK with cross-referencing your Thrift definitions. So for this reason, we decided to implement a more readable and writable JSON protocol / deserializer. And so this is our readable protocol. This is the same Thrift object as before. And here it is serialized as JSON using our protocol. And for those of you who are familiar with Thrift, you'll recognize this to be the same protocol as the same format as T's simple JSON protocol. However, the serializer provided by Thrift, it makes this only a write-only protocol. So we had to write our own deserializer to turn it from a JSON object into an actual Thrift object. So another problem with moving towards a microservices architecture is how you manage access to your data. So Rails manages its own database by using Active Record, which manages things like doing schema migrations and also doing some nice things like tying your application objects to objects in your database. And so the problem is, like, when you start moving your microservices out from your main application is how do you allow those services to actually get access to the data that they might need to operate properly. So initially, we decided to do this the wrong way. We had our alignment service periodically pull our MySQL database for the data that it needed. And this is extremely fragile, and I wouldn't recommend it because there's nothing stopping us from, there's nothing stopping Rails from changing the schema of MySQL underneath the feet of the alignment service. So instead, what we decided to do was we moved towards a event-driven architecture. And so by this, I mean we had Rails push updates to the models into Kafka as events. And then we had our new alignment service read those events from Kafka in order to get the state of the world. And so this decouples our new service from a potentially volatile schema, which is much better than the previous solution that we had. So finally, moving towards a microservices architecture means that you need to figure out how to integrate your new components together with your main application in different environments. Namely, how do your engineers who work on your Rails app develop, and how do they test when when there are certain interfaces that now exist between the Rails app and your new microservices. So the way that we decided to address this problem is we created 2 different strategies for our alignment services. We created a MySQL strategy, or a local strategy, and a service strategy. So the MySQL strategy was basically calculating alignment the same way that we had always been, using that ugly SQL query. And so we used that in our testing environment, and then we used the service strategy in our dev, our production, and staging environments. And so that service strategy was basically having our main Rails app actually make requests to some instance of the alignment service running somewhere. In addition, in order to support a dev environment, when we started implementing a lot of different microservices, we created this thing called an all server, which is basically just all of our microservices running in a single JVM, exposing those services on different ports. And so in that way, our Rails application running locally could just connect to a local instance of this all server in order to make requests to it. And then in order to run all these dependencies together in our development environment, and also, in our development environment, we use Docker and also a tool called Doc, which we use to help define, build, and run a Docker environment with all the dependencies that our Rails application needs. In our case, our Rails app needs to talk to MySQL, Redis, Kafka, and like this all server thing that I'm talking about. And in order to run them, since we've just committed all the configuration into our repo, all you need to do is just call the command doc, and then everything gets spun up with all the dependencies wired in for you. So if you're interested in using this tool, if you use Docker at your own company, we just open source Doc, and so you can check it out on GitHub. So to summarize, in order to move towards a microservices architecture from a Rails monolith, we decided to use Finagle because of the simple RPC framework that it provides. We also use Thrift to enforce a strict request and response structure. We address issues of debuggability by providing HTTP endpoints that our developers can call easily from the command line. And we also address issues of data access by moving towards an event-driven architecture. And then finally, we enabled integration with our main app and our microservices in different environments by offering different strategies and then easy to use tools. So that's all I have. Here are some links to, the first is sort of like a link to a blog post that this talk was sort of inspired by. If you're interested in using Doc, you can check it out on GitHub. And if you're interested in Brigade itself, please do check it out. So thank you so much.
Thank you, Stephanie.